Good morning, everybody. My name is Brad Genereaux, and we're going to talk today about DICOM and DICOMweb. Just kind of an introduction to what things are. Just a quick show of hands. How many of you know what DICOM is? Fantastic. I'm happy to hear that. How about DICOMweb? Okay, very few. How many people think DICOM is scary? Yeah? Okay. And how about DICOM as a black box? Like a PAX, just a black box, and you get images out somehow. Okay. Okay, we're going to try to demystify that a little bit by walking through what is DICOM and DICOMweb. As I said, my name is Brad. I'm by day product manager for AGPA Healthcare. I also do a lot of work in the standard space where I am co-chair of Working Group 27 for DICOMweb, as well as co-chair for Working Group 20 on the integration of imaging and information systems, short form working with HL7, and then also on the flip side, working with HL7 as co-chair of imaging integration. And then my colleague Mohannad will walk us through some of the exercises using DICOMweb. We'll be based up on the mezzanine level. There's an imaging table where we'll be sitting in and out for the remainder of the day. You can come talk to us about imaging. As well, there's some more sessions tomorrow on DICOM and FHIR, and then also some on IHE, which includes some imaging profiles. So we'll walk through DICOMweb, how it's used, the concepts and structures. Very interactive, although I do have 55 slides, and I want to try to get through them in 25 minutes, so we'll kind of flow through them. But anytime you can come reach out, you can tweet at me, just reach out for anything imaging-wise. So let's talk about the need for imaging everywhere, right? So when I talk about imaging, I'm talking about really four cornerstones. Diagnostic imaging, this is the classic, I get an X-ray, I get an ultrasound, I get a CT. But there are three other types that people don't think about as often. One is procedural imaging, so this is done for surgeries, for the ER department. Typically these are capture and throw away. We also do evidence-based imaging, so where we're trying to get the patient's current state. So you can think about wound care and follow-ups every 2 or 3 weeks to see how the healing is progressing. And then also image-enabling clinical reports. But if we go a little bit beyond just the classic definition of imaging, we have something called enterprise imaging, which is a set of strategies, initiatives, and workflows implemented across an enterprise to consistently and optimally capture, index, manage, store, distribute, view, exchange, and analyze all clinical imaging and multimedia content to enhance the electronic health record. There's a great paper that HIMSS and SIM put together that really walks through what this all means. Suffice to say, imaging is worth 1,000 words. You can see the difference between the left report and the right report. Adding the imaging makes that lorem ipsum Latin make a whole lot more sense because we know what we're actually talking about. An old Google mantra is, if I can't find it, it doesn't exist, right? So if we don't have the imaging when we're with the patient, bad things happen. We need to re-image the patient. That means increased risk because they might be getting more radiation. They'll be spending more time in the hospital and prone to hospital-acquired infections. There's increased cost to the patient or to the healthcare system, depending on where you live. These things are not very comfortable, especially if you've got contrast or you have to bend in weird ways. There's a lot of stress involved for both the patients and the caregivers. We're going to delay the patient's treatment perhaps because we have to re-image them. And we also back up the system for other patients, or we'll have to build unnecessary additional capacity just to make this tenable. So a very basic imaging workflow, right? So I've got a modality like a CT scanner, I have an archive, and I've got my radiologist reading station. We acquire images from the modality, we send them to the archive stores them in a PACS, a picture archive and communication system. The radiologist requests the images for reading, and then he or she creates the report. It goes much beyond this, though. There's a number of extended imaging workflows. So we think about bringing in prior studies, we're looking at other modalities. We want to send them to VNAs, long-term archives. We want to do 3D rendering on those images, reconstructions. We want to bring in foreign studies or outside studies. We want to look at regional archives, national archives. We want to get these things into the EMR. We want to get them onto mobile devices, and we want to be able to share them with sharing portals. So let's talk about what is DICOM. DICOM is imaging. It's the standard for handling, storing, printing, and transmitting information in medical imaging, and includes both a file structure as well as a communication protocol. Stands for Digital Imaging and Communication in Medicine. It has been around for quite some time. So we're talking early 80s when DICOM first started. One of the most widely deployed healthcare messaging standards in the world. There are hundreds of thousands of modalities producing images, and they're typically decades in production. 2 trillion images are produced annually. Half of that is here in the US. That equals 450 petabytes of data per year, doubling every 5 years. And right now in the world today, we've got about 4.5 exabytes of DICOM data, which is a lot of zeros. A lot. So as I said, DICOM defines the formats for imaging, waveforms, and derived structured data. It does workflow management, so coordinating the communication with the modality and the imaging systems, media exchange and printing, and then also service-based network protocols over TCP/IP and also the web, which we'll talk a little bit about. It's administered by NEMA and MIDA, which are associations here in the US, but they define a worldwide standard. The IP is held through DICOM, but there's no license required to use it. And you can just go to DICOMstandard.org to grab it. It's all there, freely available. And also, all of the plans and activities of what we're doing in DICOM are also posted there. We store images, all kinds of images, CTs and MRRs and all sorts of things. Single images as well as multi-frame, stacks of images. But it also goes beyond the imaging itself and also defines metadata. If you think about, you take a picture with your cell phone and you have a JPEG, and it also has your the geodata, so you know where you took the picture, you know the type of device that was used. Very similar here, but DICOM also packages up patient identifier data and table position for scanning the patient and all sorts of other details. There are many, many different modalities producing images. I bolded a couple that you might recognize: CRs and DRs, CTs, MRIs. But you can see that there's all sorts of specialty equipment like ophthalmology equipment, bone densitometry, etc. Aside from just images, we also do non-image supportive data, so like capturing things like ECG waveforms, fetal growth, measuring that, as I mentioned, the workflow, and also information to display the images. A lot of the images are not displayable in a web browser, for example. A CT image is a grayscale 12-bit image, which is millions of colors of gray. So, the human eye can only see 500 shades of gray, but the amount of gray that's in these are far, far more. And you just can't open this up in a web browser and expect it to work. We can distribute images. We can communicate results and the measurements that we obtain from them. We also define things like audit trails, security, de-identification, encryption as well. Very basically, we've got an image hierarchy where we have a patient who has a number of studies, and each of those studies has a number of series, and each of those series has a number of instances. And those instances might break down into frames as well. We've got metadata at each level. So at the study level, the series level, and the instance level, you can see we've got like the date of the study, the description of the study, who ordered the exam, etc. And then at the series level, it's details about the machine. And at the instance level, we got rows and columns, the height and width, as well as the position of the patient, the type of image that it actually is. We define a service plus an object equals a pair. So a service object pair, which stands for SOP class, which is the actual type of image that's stored on disk. And each player gets its own application entity. Servers and clients will have this. The DICOM tags are represented in hexadecimal format, which is one of the more popular things. So for example, 1010 hexadecimal refers to patient name. Tag 890 is referring physician name. And it's all defined in one of the parts of the DICOM standard. We also define the value representation, the data type, as well as the multiplicity. So if you think about FHIR, we define 0 to X, and what data type, DICOM also defines something very similar. Each of the DICOM instances are globally unique. So when I create a DICOM instance, it gets an identifier that is by default globally unique. There are no other instances around the world that will use that same unique identifier. It's guaranteed. They are atomic, meaning you also can't just change stuff in that DICOM instance and think that everything is hunky-dory. You have to update the SOP instance UID if you do change something about that. There's some exceptions, like if the patient got married, you probably wouldn't change the SOP instance UID if you changed the name, but there's if you change something significant, it needs a new identifier. There's key objects, so I can define what is the most interesting objects in a series, as well as I can do markup. So if you look at that image there on the right, we're looking at some of the soft tissue in the knee. Those arrows are not burned into the image, they're overlaid over top of it. So we don't destroy the underlying pixels, we overlay additional things on top of it. So GSPS grayscale presentation state defines that. If you've got a lot of time on your hands, you can read the DICOM standard. There are 20 parts and all available at the DICOM website. So we'll just check the time here. Okay. So let's look now at DICOMweb. So DICOM, as I said, has been around since 1983. It's undergone, changes since then as we add new technologies. But to a lot of people, it's been a silo. So I put images into a long-term archive, and there's only one way to get them out, which is knowing the DICOM standard, which is sometimes exceedingly difficult. When we look at the use cases that we find ourselves in 2018, we're looking more at patient-centered care, so we want to bring the images to the patients. We're looking at expanding beyond radiology images and going to enterprise images. We want to get these images onto mobile devices. We're looking at how do we leverage the cloud. Using, for information in the cloud is one thing, but pumping up gigabytes and petabytes of images is another story, but it's slowly becoming possible. We're looking at value-based care. We don't want to re-image the patient just because we can. We want to be able to ensure that we're deriving value. And then also with computing power, the cost going down, the power's going up, we're looking at new use cases like augmented intelligence. So we introduced DICOMweb, HTTP-driven services for accessing DICOM using RESTful architecture. We've worked very closely with FHIR to make sure that these things are complementary, not stepping on each other's toes, but actually working together to give you the best value for calling these APIs. It also sits on top of existing DICOM systems where plausible, so that you can use DICOMweb and still talk to DICOM backends if you've got some sort of proxy in the middle. So that, because if you think about what's different than moving from HL7 v2 to FHIR, you're just representing the data in a different way on its way in and out. But DICOM, because it defines, here's the structure of the file, it's not like we can go back over terabytes of data and somehow rewrite it into a different format or somehow expose it differently. With DICOMweb, we actually open up the doors to access the DICOM images using something that's friendly, that's RESTful, that people use today, but keeping that connection to the legacy as well. So as I mentioned, why would we do this? We want to be able to make it easier to use, no special tools, minimize what's transferred. So if you think about a pathology, a whole slide image, we're talking about 500 gigabytes. If you're on a mobile 3G phone on the subway, that will be very difficult to pull down. So with DICOMweb, you can actually get JPEGs that have a Q factor that's low enough that will render properly on an iPhone. It's easy to develop and consume the content, and really opens up the doors to accessing this. And it's very much not unlike what FHIR's done for V2, because V2 is all about pushing stuff around, but not is a little bit on the light side for being able to query. But FHIR changes that, and DICOM changes that for DICOM. DICOMweb defines 5 services: querying, retrieving, storing, tasks, and capabilities. So if you think about conformance, that's very similar to that. How these things work is very simple. So for querying, which is codenamed KetoRS, I can say, hey, what studies do you have for John Doe? I make a GET request for studies for John Doe. I will get back an XML or JSON object, your choice. and I can do what I need to do with it. We've worked together with FHIR, with the imaging study resource, so that these things work together. A lot of the query parameters are pretty simplistic, so I can specify what I want to match on. I can specify what additional metadata that I want to pull down besides the defaults, or I can even request all of the metadata if I want. Whether or not I want to use fuzzy matching, and then limit and offset. So you can see a couple of examples there. When I want to retrieve an image, so here I want to say, show me all the images of the abdomen CT. So here I make a request, get study 123 of series 456. I can say I'd like these as JPEG, thank you very much, and I can get back an object of the JPEG images. I can request them in DICOM, I can request them in lossless PNG, whatever suits my needs as an implementer. So you can see that I can request annotations if they're going to burn in or not, the quality of the image if I'm on a low quality device. I can specify the width and the height. If I only want something 50 by 50 pixels for thumbnails, I can do that. And then also specify the contrast, so how bright or the contrast of the images. And then as I mentioned, you can request different types depending on the type of object, JPEGs, GIFs, PNGs, videos as well, and then various text objects too. If I'm storing, very, very simplistic, store this image. I make a post and include the metadata as XML or JSON, and then as part of that bundle, also the image. It'll come back and say, yep, stored, done. If I'm doing tasks, if I want to say, hey, what do I need to do today? I can say, get me the list for Brad, and it says, here's your list, away you go. Again, XML or JSON. And then capabilities, here I can say, what can you do for me, server? What services do you offer? I do an options as opposed to a get or a put. That's one of the HTTP verbs, and it'll return back what it actually supports. And again, synergy with FHIR's conformance. The structures are pretty simplistic. So there's XML and JSON representations of the same information. You can see that I've got the study date, there's modalities in the study, the patient's name, and the study instance UID. So you can see it both for XML and JSON there. I've created a cheat sheet that kind of walks you through all of the various services for query, retrieve, store capabilities, and workflow, as well as some of the more common attributes. So you just go to dicomstandard.org/DICOMweb cheat sheet, and then you can download that. Just a one-pager that makes it easy to find what you're actually looking for. So I'm going to turn things over to Mohannad now to walk through a couple of quick exercises on using DICOMweb. And then I'll step back for the last couple of slides.
Thank you. Thank you, Brad. I'm not sure how many of you have actually brought a laptop if you want to follow along or if you just want to watch me. I'll be more than happy to show it on my screen, and then if you have any questions, like Brad said, we're going to be at the imaging table upstairs. Let me just get Postman going. So we'll show you DICOM very quickly just so you see that it's not really all that scary. Let me find my exercises. How much time do we have? How much time do we have? 12:30, right? We have 20 minutes. 20, okay. All right, so we'll make this really quick. Let me just find my training. DevDays. Okay, so I apologize. My template is still saying 2017. It's the same information, so we're just going to go through it. Close your eyes, pretend it's 2018. What we're going to do, first of all, is we're going to use let me zoom in here so you can read along with me very quickly. We're going to be using a server provided by SIM, which is an organization out of the US, and they are very heavily involved in imaging in general, so radiology specifically and enterprise imaging in general. Their servers use authentication. You can get your own API key if you want to play around with it. It's completely free, no strings attached. I can show you how to get one. I can walk you through the steps. For the purpose of this conference, we're going to use a generic key but that will be disabled by the end of the conference. So again, by the end of the conference, you'll want to get your own API key. You're more than welcome to step by. We'll show you how to do it. Okay. And the API keys are only used for analytics. They just do general analytics on how the servers are actually being used. So let me just use Postman. I assume most people here are familiar with Postman, the concept. Perfect. Lovely. Okay, so let me put an API key in my header, and then we'll make some DICOM web requests. All right. So the first exercise we're going to do is we're going to try and find a patient in DICOM web. And actually, I just realized there was one mistake in these. The host name has changed. I'm pretty sure I updated these when I send them in. So the version they'll have on the website is updated. It's just my version isn't updated, so I apologize for that. But we take this out. I'm going to send my request. Okay. So in this case, let me just tell it that it's XML. You notice I didn't really ask the server what dialect I want. DICOM web speaks JSON and XML, kind of like FHIR does. So obviously, this is going to be implementation dependent. Some servers will default to XML. Some servers will default to JSON. Mine here defaults to XML. One stark difference you'll notice right off the bat with DICOM web versus FHIR is that DICOM web will tend to return objects in HTTP multipart. Okay? You'll notice there is the first part here. I don't know if anybody here is familiar with multipart, but it's the same technology that's used for emails. So when I send an email, the actual text of my email is one part, and then the attachments that I'm sending are each individual parts. It's the same thing with DICOM web. The reason why is because in DICOM web, sometimes you can request multiple objects at once, and they're returned in one response. But it wants it to be very clear, you know, which chunk is which, without any kind of interference between them. Okay? So here's an example. You'll see a lot of attributes. Each attribute has a tag. That's what Brad mentioned. So it's a hexadecimal identifier of the attribute. I know it looks scary, but it's there for a reason, because DICOM is very much backwards compatible. So in theory, you could crack open a DICOM file that was created 20 years ago, and you should still be able to consume it today. And you should also be able to transform it into this format, because that's another stark difference between HL7 and DICOM. V2 and FHIR are a revolution. It was completely reimagined from the ground up, whereas DICOM web is an evolution. It builds on top of existing DICOM, brings it to the 21st century, but does not necessarily rebuild everything from scratch. That being said, yes, some of these things do look archaic. For example, this is the date format in DICOM. So you see year, month, day. It's a little awkward. Same thing for the time format. You notice it doesn't use any separators. So, it takes a little bit of getting used to. It's an acquired taste. Brad didn't start the presentation by saying it was pretty. We never said it was pretty, right? But anyway, so as you go on, you'll find some more interesting information. So for example, here we have the patient name. Let me zoom in, make this a little bit more readable. Everybody. Is this better? A bit more readable? Yeah, I apologize about that. So here we have the patient name, and again with the curious format choices. So the format here is last name, and then you have the caret, and then the first name. And if you have more parts to the name, you'll have more carets. Again, a little bit of acquired taste, but if you're ever going to be working with DICOM web, you're not going to be reinventing the wheel and writing your own library to parse this stuff. You're going to have an existing library like DSAM4Che, and it will provide all that information readily for you. You're not going to have to go through all the nitty-gritty details. Okay? If you go back to our exercises, we'll do another one quickly. You'll notice that we talked about the unique identifiers in DICOM. So here, let's run through a quick example where we're going to ask for the instances within a study. And you notice instances, the first thing when I say instances, most people think of images, and that is correct. Most of the time, these instances are images, but they're not always images. Because sometimes there are objects that are, for example, the overlays Brad talked about that go on top of the image. Sometimes there are objects that produce metadata separate from the images. So not all of the objects are displayable, which is why we use generic terminology. We call them instances. in this case, what I'm asking for is I'm asking for discovering within this study, with this long-looking UID, I'm looking to discover the instances within that study. So I will take this to Postman. I'll perform this request. Takes a moment. Oh, sorry, yeah. Again, I promise I updated this in the version you'll find on the website. I just forgot to update my own. Okay, so once again, you'll notice multi-part response. So what's going to happen here is, let's say the study has 5 instances. That means my response is going to have 5 parts, 5 HTTP parts within the response. And then each one of them is going to describe an instance, such as an image, within that response. Okay? And they will provide things like, for example, you see here the instance UID. So this is the unique identifier for that image specifically, or whatever metadata object it is. You'll notice that pretty much, oh, there you go. Here's one thing Brad also talked about. DICOM talks about rows and columns rather than width and height. So again, just old terminology, but it's pretty much the same thing. So in this case, this is still in pixels. So 512 by 512 pixels is what we've got here. You see, again, part of the reason why you need DICOM, this is a 16-bit image. So this is higher fidelity than your typical JPEG. That's one of the reasons why you need DICOM. Okay. There are other attributes here. I'm not going to go through them right now. But we will take a look at some of these. Yeah, we talked about soft instance UID. Let's talk about the modality, actually. That's an interesting one. Is that one here? Yeah, there's a modality. So this tells you what kind of device actually captured this image. If you remember the hierarchy in DICOM, you have a study, and then the series, and then the images. You can have a study that's been captured through multiple devices, because a study, you may do part of the study using an X-ray machine, and then another part of the study using a CAT scanner, right? So in this case, this image comes from a CAT scanner. Okay, that's what CT is. And then the other one is a retrieve URL. So if you actually want to go and grab that image, DICOMweb will conveniently give you a URL that you could just quickly run to get that image. If I was to plug in that URL in my Postman right now, I would actually get a binary response, because that's, you know, the actual raw DICOM file. And remember, DICOM file is not a JPEG file. Don't just try and put it into the browser. Why does it keep doing that? Oh. Got me confused. Yeah, thank you. We also have series numbers and instance numbers. I'm not going to actually highlight them here, but again, just ways of structuring data. Because, for example, if you talk to radiologists, you'll usually hear radiologists talk about something like a hanging protocol. It's, you know, when they used to have film, they used to have literally a way of hanging those films side by side. So similar thing when you have a viewer. If you have a DICOM image viewer, they don't just put all the images on the screen and explode them, right? This is not your family photo album. These are medical images, so there's hanging protocol. So you have to look at all these little clues within the images to decide how to lay them for the radiologist or the user to see. Some of them make sense side by side, whereas some of them are stacked, meaning you go through them pretty much like a movie. You play them in sequence. Right? And sometimes you have a combination of. Sometimes you'll put a couple of them side by side and you put the rest stacked. It can get really complicated. And then we've got, I'll cover probably one quick example before I turn it back to Brad. Okay, so here we have an example. I know this is very verbose looking, so bear with me, but it is an example of how you retrieve. Again, the hierarchy is, you notice I'm specifying a study UID, and then I specify a series UID, and then I specify an instance UID. In this case, I go one more, and I'm asking for frame 1, okay? Frames is a relatively new concept, so not all images have that. It depends on the study you've got, but let's try to do this, and let's see what we get. Should get a binary response on this one.
No, drop API again.
Oh, yeah. Sorry. This one will be a little slower because these files are typically large. So there you go. There's my binary response here. Okay. There are more information here. There's an example of how you can ask for a JPEG, but I'm not going to cover that right now. If anybody wants, we could do that upstairs. I can show you even more examples if you'd like. There's even an example here of how you can retrieve an entire study in one shot. Use that very carefully. Some of these studies can be gigabytes large, literally. It all depends. You know, if it's a CAT scan, it's again in the gigabytes, mammogram in gigabytes. If it's a simple X-ray, it's usually megabytes, but be careful with that. Okay, any questions on this before I hand it back to Brad?
I have a quick one. So is there a way in FHIR to reference a study or an observation or some work? How do you do that?
Yes, absolutely. Here, I'll take it back. Yeah, okay. Actually, we'll cover that tomorrow. So tomorrow we have a session on FHIR and DICOM, which bridges the two standards. Suffice to say, though, there's a resource called Imaging Study, which in there's a data type called Endpoint, which is your connection to the DICOM backend to retrieve the images. Yeah, I will step through the whole thing tomorrow, end to end. Okay, my presentation, so we'll wrap this up. We've got about, what, 5 minutes left? 7 minutes left? Okay. All right. So, in conclusions, DICOM is imaging. If you want to find out more information, you can visit the DICOM website, dicomstandard.org. There's also a reference on DICOMweb that you can get from there. And then if you want to read about DICOMweb, the specification in particular is detailed out in Part 18 of the DICOM Standard. Me, along with a number of different stakeholders in the community, put together a white paper, I guess, a paper on DICOMweb, kind of the background of what DICOMweb is, as well as the use cases it solves and details about it. It's open access, so you can download it and retrieve it. I've tweeted out the link if you want to have a look at it. Get involved in DICOM. If you're interested, there are many ways to participate in the community. It's free. You can join a working group as an observer, and depending on what your interests are, if you're interested in cardiac, you're interested in radiotherapy for cancer treatments, if you're interested in small animals, there are a number of different working groups that meet on a regular basis to talk about imaging issues. And like I said, free to participate. You go to dicomstandard.org/participate. And you can always stay up to date if you go to the website as well. We publish, I think it's 5 times a year, changes inside of the standard in a nice newsletter format. There's an upcoming DICOM conference if you want to do more DICOM coming up in Brisbane in Australia in September, where they're going to actually go through a number of different paper presentations as well as it's an entire conference around DICOM. As Mohannad mentioned, we're using the SIM data set, which we are very appreciative for to be able to pull this into FHIR DevDays. This is the 3rd year that we've done it. If you want to know more about SIM, where they have a SIM hackathon using both FHIR and DICOMweb, you can learn more. They meet on an annual basis. It just wrapped up a few weeks ago in Washington, D.C. The next one is coming up in Denver in 2019. But they also have a smaller show. They've got regional shows as well as one on machine intelligence and medical imaging. And that's in, I think it's the first week of October or last week of September. So just a quick special thanks, for people who helped me with this presentation, DICOM, Nima Maida, HIMS and SIM, as well as I took some slides from various colleagues in the DICOM industry. And as I mentioned, so tomorrow we're going to be back here at 11 o'clock talking about the bridge between DICOM and FHIR. And then there will be some more interesting IHE stuff that includes FHIR, a little bit of DICOM as well in the afternoon by John Murky. And then, as I said, Mohannad and I will be by the imaging tables if we're not at one of the sessions. So with that, any questions? That's a lot of information. Yeah.
I have a quick one. So for those of us that may have been hoping that FHIR was going to finally put DICOM out of its misery, and that's not, I'm joking. That's not going to happen, right? There's still going to be parallel.
There was a really fascinating blog post that Graham did, I think 5 years ago now. And if you've been working with FHIR for long enough, you know what the 80-20 rule is. And we said, okay, well, let's look at images, like from DICOM. And we looked at all the tags for all the images, all the necessary tags. I think it's something like there's about 40 or 50 tags that are pretty common across all DICOM objects, but thousands upon thousands that are not, that are unique to the modality, unique to the manufacturer, unique to the packs. It's not something that makes a lot of sense. So what we did instead was our joint group between HL7 and DICOM worked together to look at the information side of the house and using imaging study to communicate metadata that EMRs and other information systems would be using, and then look at DICOM for all of the modalities, all of the PACS vendors, all of the stuff around working, like the 3D reconstruction, that are looking at images from the raw formats. And these things work together so that if you want to flow from one to the other, there's natural ways to do so. So we looked at the strengths of both and really worked towards that, as opposed to say, hey, we could just throw away DICOM and we'll just put everything in FHIR, which some people were thinking about. But we realized pretty early on that that wasn't going to work for everyone. If you think about, I'll add one more kind of caveat. When I worked in the hospital, so I come from a hospital up in Ottawa, Canada, when you buy an X-ray machine, it will sit there for 20, 25 years. It's like the Ronco model of set it and forget it. You never come back to it. You say, I've got an X-ray equipment, I don't touch the firmware, I don't upgrade the software. It's barely even DOS. Like, it's really, really firmware encoded, because there's a level of safety when you're throwing radiation at people that you have to not have a blue screen of death, literally. So you can't just say, oh, I'm going to put FHIR or even DICOMweb on that and hope that it works. You really need to be able to bridge 30-year-old technology into today, and that's what DICOM and DICOMweb really offers. Any other questions? Yeah. Yes.
Is there like any specification is defined? Someone wants to pull an image for hardware and the software, what do you need to do?
So what you're capable, like, so for example, a mobile phone. Yeah.
Mobile phone or a server for Windows and Linux, is there like specification defined in there?
To an extent. So clients can define what they want to ask for. So if they want to ask for a small file, they're able to. If the client happens to be fully capable of rendering DICOM and is really DICOM imaging based, then it will be able to ask for that. So really the onus is on the client to define what it actually wants to do. Okay? Yeah?
You mentioned modalities take sometimes pretty complicated images, like the one that had 6,000 rays.
Yep.
Through DICOMweb, if you request one of those as JPEG, what happens? Does it return a JPEG that you can render? Or?
Yes. So if you ask for an image JPEG, you're going to get a JPEG that's renderable in the browser. Absolutely. And so one of the things that we're using DICOMweb for is to really image enable the EMRs. So if you think about an EMR, and the classic way is you've got, here's 10 studies, right? And it's just a list. And if you think about how humans work, we're visually oriented. So if you were to throw up a JPEG on there, and like, here's a JPEG of all the things, hey, I'm looking for the hand, so I'll pick the hand one. We don't expect that EMRs will be able to understand the DICOM protocol anytime soon. It's hard. But if you can just say, give me a JPEG, and it's just a off-the-shelf JPEG, that's really what the intent of DICOMweb is.
What happens to all the gray stuff that was in the image, and is that a new technology to transform all the complicated grays to JPEG, or does that exist already?
I'd say that exists already. So you are losing a level of fidelity. So it'll step it down to an 8-peg JPEG, 8-bit. And you think about a level of quality, you'll probably get a lossy JPEG. And when you retrieve it, you are saying, I would like a JPEG, and I want this level of quality factor being brought down. So the client is consciously asking for something that it knows that it stepped down. When we're going to a diagnostic client on one of those $25,000 monitors, we will ask for the original DICOM back and render the original DICOM. Make sense? Perfect. Okay, I think that the lady came in and waved her hands at me, so I think we're out of time. You can tweet at me at Integrator Brad, find me on LinkedIn. I'll be here all week and up near the imaging table. So thank you very much, everybody.